Hi, welcome to InterNACHI TV. I'm Kenton Shepard, and we're here today to look at the components that would be examined in a garage during a typical home inspection. And actually, we're going to go a little bit further than what you might include in a typical home inspection, going on the assumption that a little more knowledge than you need is better than not enough knowledge. We'll start at the back of the garage with the wall that separates, the wall and ceiling that separate the garage space from the living space. Because garages often have flammable liquids and other combustible materials stored in them because they're project spaces, the people who developed safety standards thought it would be a good idea to construct walls separating garages from living spaces in a way that would slow down the spread of fire and give the occupants time to escape. Firewall should be covered with 5/8 inch drywall, and it should be fire-rated type X drywall. The type of drywall is usually labeled along the edge of the panel, so you won't see it at the edges where it's fire taped, but you can usually see it along the bottom edge, if you're lucky. One of the other requirements is fire taping. You don't want any exposed joints, so all the joints have to be fire taped with drywall tape embedded in drywall compound. You're not allowed to have any penetrations through the firewall unless they're metal. So metal ducts, metal conduit, got to be metal. Often a home inspector can't verify the thickness of the drywall because you can't see the edge anywhere. In that case, you should say that you don't see type X written on the drywall anywhere and mention that you can't see the thickness and that you're disclaiming it. You can have a door through a firewall, but the doors have certain requirements also. You can have one of 3 different kinds of doors. You can have a solid core, 1 3/8" minimum thickness door. You can have a metal door, or you can have a 20-minute fire-rated panel door. One of those 3. We'll also be looking at the walls that are not abutting living space. So as we look at this wall here, you want to sight down it just to see that it's fairly straight, and you want to be looking at the bolts that bolt it down to make sure that they've all got nuts on them. As we walk down here, we can see that there's sill seal, which is insulation between the top of the foundation wall and the bottom of the wall plate, just to help prevent air movement in and out of the garage, even though this garage is not heated. As we walk along here, we can see that there's an anchor bolt here that's missing a nut. And a little further down, we can see that there's a break in the bottom plate, and breaks in bottom plate for a long time have been required to have a bolt on either side of the break within about 6 inches, so there should be a bolt there and there. This bottom plate is not treated wood. Treated wood has been a requirement for a long time. If this were treated, it would be kind of greenish and would have little slots in it from the treating process. This has got OSB, oriented strand boards, sheathing on the outside. It looks like, other than the things we've mentioned, this wall is all right. Now, as you look at it from back there, you can see that there's a changing margin between the floor and the top of the foundation wall here. That's called a curb, and that shows you that the garage floor is sloping down, so that if you're inspecting a home in an area where it snows, when they pull the car into the garage and it's covered with snow, when it melts, it all runs out the door instead of into the house. You want to look closely at the foundation walls, because since the soil on the outside of the wall is exposed to snow melt and runoff, you can wind up having problems from expansive soil or soil freezing. Expansive soils are usually clay-based soils that expand in volume with changes in soil moisture content. So if the soil beneath the foundation expands, it pushes the foundation up, and foundations aren't really designed to resist those kinds of forces. If you see cracks on the outside especially that are bigger at the top than on the bottom, that indicates there's been heaving, and expansive soil is often a source. The other source is freezing. In cold states, when water freezes, it expands, and so it winds up cracking foundations. As an inspector looks at a concrete floor, there are certain things he should see every time. One of them is an expansion joint around the perimeter where the concrete slab meets the foundation wall. Because concrete expands and contracts with changes in temperature, there needs to be room for it to expand against the wall. If it doesn't have room to expand, it's liable to crack the wall. So in looking down along that edge, what you should see is the top of a fibrous strip, typically 3/8, half an inch in thickness, that will give as concrete expands. Another thing inspectors should see as they look at concrete floor slabs are control joints. As concrete cures, it shrinks and cracks. And we want to be able to control those cracks for aesthetic reasons. So control joints are grooves cut into concrete or installed when the concrete's still wet that make the concrete a little thinner, and since it's thinner, that's where it's weaker and that's where it will crack. And if you look here, you can see that these control joints have done their job. Homes often have stairs leading from the garage to the living space, and you need to be sure and inspect those stairs. Looking at this set of stairs, it doesn't look too bad at first, but looking a little closer, it's not really too solid. Also, the risers in a set of stairs are only allowed to be 3/8 different from 3/8 of an inch different from each other. So you're allowed a maximum of 3/8 of an inch variation. So at this riser here, we've got about 6 inches. At that one there, we've got about 8 inches. So we are way past the 3/8 that's allowable. In recording this as a defect, a narrative should really have 3 parts. The first part is describing the defect. So you would say that the stairs were not stable and the risers had too much variation. You should describe why that's a problem and just that it could cause injury with somebody using the stairs. And then you should make a recommendation, and that is that it be corrected by a qualified contractor. You might want to recommend that this set of stairs have a handrail because you don't know who's going to be using it. If somebody were 85 years old or they were 3 years old, they might not be as good as everyone else at going up and down stairs, and in that case, they could use a little extra help. Inspectors looking at garages in milder climates where freezing isn't an issue may see gas-fired water heaters mounted in the garage. Mounted is the key word there because gas-fired water heaters are required to be mounted on a platform a minimum of 18 inches above the walking surface. That's the burn chamber needs to be 18 inches above the walking surface. Because garages are used to store flammable liquids like gasoline, you can wind up with fumes building up, heavier than air fumes building up along the floor of the garage, and they want to be sure that those water heaters are high enough so that when the water heater comes on, they don't ignite those fumes. One common area for roof framing defects is where the garage roof framing meets the 2-story house, especially in roofs with trusses. In roofs with trusses, the support for the garage trusses is often right at the wall of the house. And personally, I find a lot of defects there. Usually, the trusses are supported by some kind of hardware. You may see trusses that rest on ledgers that are actually nailed to the wall. And unless it's a fairly old house, engineers are going to call out for a ledger being bolted to the wall or being screwed to the wall using lag screws. So you want to look pretty carefully at any kind of ledger supporting trusses. If trusses are supported by hangers, you want to be looking for a hanger that's more this size than this size. And you also want to be looking pretty closely at the fasteners used to connect these hangers to the wall. In addition, the hanger should not be against drywall because drywall doesn't have any structural value in that situation, and if a hanger is abutted directly to drywall, structurally you really have a half-inch airspace between the hanger and the wood that's actually supporting the fasteners, and you need to call that out. This is the exterior of a townhome I was asked to inspect. During the inspection, I ran into a neighbor who told me that the roof of a garage identical to this one, 2 buildings down, had collapsed under a snow load the previous winter. So I thought I would keep my eyes wide open as I went through the garage. That turned out to be unnecessary. Some defects you have to search for, and some are pretty obvious. The first 2 defects were obvious from the doorway. Trusses cannot be altered in any way without the approval of a structural engineer. When you see plywood gussets added at truss connections, like these triangular gussets, then an alteration of some sort has obviously been made, and you have to recommend an evaluation by a structural engineer. Trusses are also designed to bear loads only at very specific points. Typical roof trusses should not touch any interior walls and should bear only on the exterior walls. The 2 trusses at the left of this photo are bearing on an offset portion of the garage wall, the wall that the garage shares with the living space. A portion of the structural roof load was being transferred to the bottom cords of the trusses at a point at which they were not designed to support a load. Then I walked over and looked more closely at the connections where the trusses attached to the wall. These trusses would have been best supported by bearing directly on wall framing. Next best would be an engineered designed ledger or engineer specified hardware. And that may have been how they were originally built, but by the time I inspected them, the 24-foot roof trusses were being supported by joist hangers designed to support 2x4 joists. And the hangers were fastened with 4 gold deck screws each. Gold deck screws are designed to resist withdrawal. Fasteners for metal connectors like joist hangers are designed to resist shear. Withdrawal force is like the force which would be generated if you grabbed the head of a fastener with pliers and tried to pull it straight out. Shear force is what's used if you take a pair of heavy-duty wire cutters and cut the fastener. Fasteners designed to resist withdrawal, like deck screws, are weak in shear resistance. So there were drastically undersized metal connectors fastened by badly understrength fasteners. And to make matters worse, the screws were fastened through drywall, which doesn't support the shaft of the screw and degrades the connection even further. And once I looked really closely, I found more truss alterations. The gang nail had been pried loose, and the spikes which formed the actual mechanical connection were destroyed. In their place were a couple of bent-over nails. This condition represented a terrific loss of strength in this roof, and so it too was a candidate for catastrophic roof failure. Usually the trusses are supported at the bottom cord, but that's not always the case. Occasionally you find trusses that are supported by the top cord, and usually that's hard to see. You just have to give it your best shot, look carefully. If the connection looks solid, especially if you see hardware, it's probably all right. But if you don't see hardware and you can't visually confirm that there's a good solid connection there, then you want to state that. Without a set of truss plans, you can't always say that something is right or wrong. But if it doesn't look quite right to you, it's a good idea to call out that the truss connections be confirmed by a qualified engineer, or recommend that the seller provide documentation such as truss plans showing that the trusses were installed correctly. There are certain requirements for garage door switches, and the main requirement is that they be at least 5 feet above the walking surface. This switch is located right here, so it meets that requirement. Switches also have to be well away from any moving parts of the garage door, and this is a pretty typical spot right outside the door from the living space to the garage. But occasionally, this door will be over closer to the main garage door opening. In that case, sometimes you'll find these switches right next to the track, and that's not a good thing because somebody can get their fingers caught in the track. Modern safety standards require garage outlets to have GFCI protection. GFCI stands for ground fault circuit interrupters. Ground fault circuit interrupter outlets sense incoming current and compare it to outgoing current. And if there's too much of a difference, they shut off power to that circuit because they think somebody's getting shocked. So we use a GFCI tester to test for GFCI protection. Now we'll notice that you can usually tell a GFCI outlet because it has a little reset button in between the two plugs. This one doesn't, which means that if it's got GFCI protection, it's connected to an outlet elsewhere in the house that has a reset button, or it's connected to a GFCI breaker in the main panel. If it goes to another outlet in the house that has a reset button, we might be able to hear it click when we test it. And that will save us time in looking for the reset button because we don't want to leave this off when we leave the house. So we'll plug this in. We can see that it's wired correctly. And we push the reset button and listen. I didn't hear a thing, which means that in order to reset this circuit, we need to go around the house and find a GFCI outlet in which the reset button has been tripped, or we need to go down to the main panel and find a GFCI breaker with the handle that's been tripped. Modern safety requirements require outlets in garages to have GFCI protection, but there can be one exception, and that's an outlet that's usually installed to supply a freezer because GFCIs are sometimes not that dependable. They don't want the GFCI is supplying the freezer to trip and losing all the food. In looking at the surface of the concrete floor, inspectors want to be looking for spalling. Spalling is the detachment of little flakes of concrete. It may be caused by the wrong kind of aggregate being used, which can cause chemical reactions, which cause sections to pop loose. They're often about the size of a golf ball. They can vary a little bit. The wrong kind of aggregate can also cause discoloration. So spalling, discoloration. You can also have larger flakes coming loose if you have other kinds of improper concrete mix at the time of original construction. You can also be on the lookout for damage from impacts. When garages are used for working on vehicles, people drop engine blocks, they drop cars, they drop all sorts of things. So you want to be looking around for various kinds of impact damage. In examining the garage door and all its components, we can start at the back here, and one of the first things we want to look for are the mounts for the garage opener right here. You want to make sure that this is all solid. And the mounts for the track back here. You want to make sure that that's solid. So you want to look at the methods they've used to connect the track and the operator to the ceiling or to the framing. You also want to look for the fasteners. You want to see what kind of fasteners they used. You can't always see them. In fact, over here, it's covered in drywall tape and you can't see them. But it's one thing you want to be aware of because they aren't always as strong as they should be. If we follow the opener rack forward, you want to look for a good solid mounting pad at the header. And they like to see 2x6 for that, and you really want to see it really well connected. This one is connected with 16-penny nails. That's okay as long as there are enough in it. It's even better if it's connected with lag screws. While we're right here, we're looking at the operating arm and how it connects to the mounting bracket at the door. The angle of the arm from the vertical should be between 10 and 30 degrees. So if we were looking at this as plumb, the angle this way should be 10 to 30 degrees, in between there somewhere. In this part of the door, we want to see a strong back along the top section of the door, and we have it here, especially in a door that's double wide, 16 feet like this. And also we have one, the bottom section here. That helps keep the door from sagging when it's open. The connector bracket here, where the operator arm connects to the door, should connect at about the same level as the top roller in the door. So, and it should connect to a mounting bracket like this. So this is done fairly well. So if we look at the distance down from the strong back here, it's about 3 inches from the strong back to the place where the operator arm connects. So let's walk here to the topmost roller, and we can see that it's about 2.5 inches from the strong back to the roller, and that's acceptable. You just don't want to have 6 inches difference. The problem with that is that if there's too much difference, then you can wind up with safety features which don't work very well. So you want to look and just compare those. You should have metal rollers or nylon rollers, and they should have bearing. Occasionally you'll see a door that has plastic rollers, and they will not last very long, and you should mention that in the report. The topmost and bottommost rollers in a door should have longer shafts than the intermediate rollers. That's because if, as the door is coming down, someone has left a snow shovel leaning against the jamb, the whole door will rack, and if the roller is too short, it's liable to fall right out of the opening. So, over at the side like this, we also want to be looking at the way the track is mounted, the fasteners that are used, and that making sure that there's a jamb connection that's solid enough. Also, the mounting pad for the spring shaft up here needs to be strong enough. You want to make sure that the springs are in good shape. You're looking for cracks, you're looking for one or both springs broken. If you see broken springs, don't operate the door. These springs are under a lot of tension. You can get pretty badly hurt under certain circumstances. Let's test the manual disconnect. This is it right here. The lanyard is a little on the short side. It should be at least within 6 feet of the floor. I'm 6 feet tall, so it's a little short. When you lift the door, it should stay where you put it. This one almost does, but not quite, so we'd mentioned that in the report. Now we need to reconnect the door, and various doors have different devices for reconnection. This particular device needs to be pulled back like that in order to reconnect, and then it should do it. The door is operated. There we go. Doors should have some sort of automatic reverse feature so that children can't get caught under the door as it comes down. This one has got a photo sensor, which is a pretty common method for auto reverse. And you can see one side of it there. There's a beam, an invisible beam that will shine out of that one into this one. And if that beam is broken, then the door will reverse as it comes down. There are a couple of different devices that can be used instead of the photo sensor. There is a pneumatic device that's basically an air tube that's alongside along the bottom edge of the door. There's also an electrical device that's also along the bottom edge of the door. They're pretty unusual to see. This is by far the most common method. So you want to test that. So we'll bring the door down and break the beam. You also want to make sure that if for some reason the beam isn't broken, but there's still an obstruction there, the door will reverse automatically to prevent damage. And there are factory settings for that, but you can't always set them to factory specifications, especially in areas in which there's a big difference between daytime and nighttime temperatures. That can have an effect on the safety devices in the door. So they really need to be set according to the area in which the house is located. So we'll try this one. What I'm going to do is turn around and catch it with my hands as it comes down and watch that top edge. Because if you offer too much resistance to the door, you can actually cause the door to collapse. You can actually break the door or damage the door. So here comes the door. I'm going to be watching that edge there. And this one was pretty reasonable. You may find some that are really hard to hold and you should just let go and let them come on down and write it up as needing adjustment. Photosensors were designed to protect little children, and so they should be mounted a maximum of 6 inches off the floor. They were first required in 1993, so homes that age or newer, you expect to see them. You should mention them if you don't. Even though most inspectors test the automatic reverse feature by hand, if you take a test, a written test on home inspection, they'll ask you the proper way to test the automatic reverse feature, and that is with a 2x4. And we have one right here. We're going to test this door with a 2x4. It should be laid flat just like that. It works. In looking at the garage door itself, you want to examine the panels for cracks or other kinds of damage. You also want to look at the bottom edge of the garage door, especially in wood doors. Wood doors which sit in snow melt and other moisture may soak up water, and you can find decay and other kinds of deterioration along the bottom edge of the door. This particular door has torsion springs which are mounted on a shaft that runs across the header above the door. Older kinds of garage doors may have extension springs which run back from the door and connect to the mount out here. And extension springs should have a containment cable which runs down the center of the spring. That way, if the spring breaks, it's not flailing around through the air, snapping through the air, and risking injuring or killing somebody. So you want to watch for containment cables in extension springs. Adjusting the garage door springs will weaken them. So unless the door is seriously out of balance, you might not want to recommend adjusting them. Modern springs have about a 4-year lifespan as opposed to a 20-year lifespan on older springs. Garage door openers themselves have about a 12-year lifespan. So if it's an older opener and it's not working correctly, you might want to mention that fact in your report so that people don't spend a lot of money having it repaired as opposed to just replacing it. This adjustment is just about right. The slot is pointing to about 5 o'clock. If it's pointing to 7 o'clock or 8 o'clock, that's too much resistance and it should be readjusted. Sometimes this adjustment screw will be covered by a light cover, and you'll have to take that cover off in order to see the setting of the adjustment screw. Homes built to modern standards will require connectors, metal connectors, fastening roof framing to wall framing. And this is what you'll typically see, and they'll go on one side of the rafter just like that. They're typically installed every other rafter except at the corners. The rafter 4 feet in will have one on both sides.